When German engineers finally got the chance to study a captured American Sherman tank up close, many of them approached it with confidence, even a hint of arrogance. On paper, the Sherman didn't look impressive. Its armor was thinner than German heavy tanks. Its main gun lacked the raw power of a Panther or Tiger. And its silhouette was tall and easy to spot. From a purely technical standpoint, this was not the kind of machine Germany prided itself on building. But as the inspection went on, that confidence began to erode. The first surprise wasn't what the Sherman had, but what it didn't. There were no overly complex systems packed into tight spaces. No intricate mechanisms that required specialist tools or expert hands to service. Instead, everything felt deliberate, almost blunt in its practicality. Components were laid out logically. Access panels were easy to reach. Parts were clearly labeled and designed to be swapped quickly. To German engineers accustomed to precision-built machines that pushed the limits of engineering, this simplicity felt almost insulting at first. Then the realization started to sink in. This tank wasn't meant to impress engineers. It was meant to work consistently, everywhere, and in the hands of crews who might only have weeks of training. German tanks were marvels of innovation, but they demanded highly skilled crews and constant maintenance. A minor mechanical issue could take a tank out of action for days. The Sherman, by contrast, seemed designed with the assumption that something would go wrong, and that when it did, ordinary soldiers should be able to fix it under pressure. As they examined the engine and drivetrain, the philosophy became even clearer. The Sherman used proven, reliable components rather than cutting-edge designs. These weren't the most advanced engines available, but they were dependable and forgiving. If one failed, replacements were readily available. And crews didn't need a team of specialists to get the tank moving again. For German engineers, this raised an uncomfortable question. What mattered more in a long war? Technical superiority or reliability at scale? Crew survivability was another eye-opening detail. The Sherman incorporated features designed to give crews a better chance of escaping when things went wrong. Escape hatches were more accessible. Internal layouts allowed faster evacuation. Later versions even included ammunition storage improvements to reduce the risk of catastrophic fires. German tanks, while heavily armored and powerful, often sacrificed crew safety for performance. Losing a tank was one thing. Losing an experienced crew was far worse, and the Sherman seemed designed to minimize that loss. Even the way the Sherman handled damage told a story. German tanks were built to fight other tanks head-on, relying on thick armor and powerful guns. But once damaged, they were often difficult to recover or repair. The Sherman, on the other hand, accepted that damage was inevitable. It was easier to tow, easier to patch up, and more likely to return to the battlefield quickly. German engineers began to see that the Sherman wasn't built to win duels. It was built to stay in the fight. Testing the tank reinforced this lesson. The Sherman started reliably, ran consistently, and handled predictably. It didn't demand perfection from its operators. That mattered more than raw performance when multiplied across thousands of vehicles and tens of thousands of crewmen. German designs often assumed ideal conditions and expert handling. The Sherman assumed chaos. What truly unsettled the engineers was how all of this fit together into a coherent philosophy. Every design choice pointed to the same goal: keep tanks operational, keep crews alive, and keep pressure on the enemy. It wasn't elegant in the traditional sense, but it was brutally effective. The Sherman didn't need to be better than every German tank. It just needed to be good enough, everywhere, all the time. Slowly, the focus shifted from the tank itself to what it represented. This machine was clearly designed for mass production. Standardized parts meant factories could produce components quickly and in enormous numbers. Repairs in the field didn't depend on custom-fitted pieces or specialized knowledge. A damaged Sherman could often be fixed using parts scavenged from another one. Something far harder to do with German tanks built to tighter tolerances. For German engineers, this realization hit hard. They were looking at a weapon that reflected an entire way of waging war. One Germany wasn't equipped to match. Their own tanks were masterpieces. But masterpieces are expensive, time-consuming, and fragile in large numbers. The Sherman was not a masterpiece. It was a tool, designed to be built fast, used hard, and replaced without hesitation. The real shock wasn't that the Sherman was better than German tanks. It often wasn't. The shock was that it didn't need to be. It existed within a system that valued consistency over brilliance and sustainability over spectacle. And as German engineers stepped back from the captured tank, many of them began to understand a grim truth. Wars aren't won by the best machine on the battlefield. They're won by the machine that shows up again tomorrow. And the day after that, long after the brilliant designs have broken down or run out of parts. That moment of understanding marked the beginning of a much larger realization. One that went far beyond armor thickness or gun caliber. And it forced them to confront why. Despite their technical excellence, the war was slipping further out of reach. As German engineers continued their tests of the captured Sherman, it became clear that the real revelation wasn't the tank itself. It was the system behind it. On the surface, the Sherman looked ordinary, even underwhelming compared to the heavy, powerful German machines they were used to designing. But as they ran the engines, inspected the armor, and examined the suspension, a pattern emerged. The Sherman wasn't just a single vehicle. It was a reflection of an industrial philosophy that Germany simply could not match. Every detail, from production to maintenance, revealed a staggering logistical advantage, and the implications slowly began to sink in. German tanks were masterpieces of engineering. The Panthers and Tigers they admired were formidable, heavily armored, and packed with firepower. Each one represented countless hours of design, precision machining, and painstaking assembly. On the battlefield, these machines could dominate a duel against almost any Allied tank. But that very complexity was also their Achilles heel. The engines were finicky, the suspensions delicate, and a single mechanical failure could take a tank out of the fight for days. Or even permanently. Each Panther or Tiger was a triumph of technology. But it demanded ideal conditions, expert crews, and meticulous maintenance. In a prolonged war, that combination became a critical weakness. The Sherman, by contrast, was a product of a completely different mindset. It wasn't trying to outgun a Panther in a one-on-one confrontation. Instead, it was designed to be everywhere, all the time. It could be built quickly, repaired easily, and returned to the battlefield with minimal downtime. Standardized parts meant that even if a component broke, replacements could be installed by ordinary soldiers or support crews without specialized knowledge. The tank itself was just one part of a larger system. One where mass production, interchangeability, and reliability outweighed raw technical superiority. As they studied the captured tank, German engineers could see how this philosophy translated into action. The Sherman could take a hit, lose a track, or even have a damaged engine and still be dragged back into combat. Crews could swap out parts under fire, often improvising with scavenged materials. That kind of resilience was impossible with most German designs, which demanded precision, specialist repair teams, and time. The engineers began to realize that Germany's own technological ambitions were working against them. In the long run, while they were building exceptional tanks, the Allies were building tanks that worked, and kept working, consistently, day after day, week after week, across an entire continent. The production numbers told the same story. Germany might produce a few hundred Tigers or Panthers a year. Each a marvel, but each also a drain on resources. In contrast, American factories were producing Shermans by the thousands. They could replace losses faster than the Germans could destroy them. And they could sustain a massive frontline presence. It wasn't that German tanks were losing in quality. It was that sheer quantity, combined with reliability, had become a decisive factor. The battlefield was no longer just about the best machine. It was about the machine that could stay in the fight long enough to matter. Logistics extended beyond production. Supplying and maintaining these vehicles in the field was another area where the Sherman system excelled. Spare parts were standardized and widely available. Maintenance crews didn't require advanced training or specialized tools. Crews could quickly repair their tanks or help each other get back into action. German engineers began to understand something uncomfortable. It wasn't enough to build superior machines if those machines couldn't be maintained or replaced under real combat conditions. Their superiority meant little. By the time a Panther was repaired or rebuilt, multiple Shermans had already returned to the front line, ready to continue the fight. It wasn't just about machines either. The Sherman's design philosophy extended to its crews. Easy-to-use controls, predictable handling, and forgiving engineering meant that soldiers with minimal training could operate effectively. German tanks, while deadly in the hands of experts, required highly trained crews to reach their full potential. A loss of a skilled crew member could render an expensive tank almost useless. The Sherman minimized that dependency. In the context of total war, where casualties were inevitable, this was a critical advantage. Engineers realized that the Sherman wasn't just resilient mechanically. It was resilient organizationally. By the time testing concluded, a sobering truth had crystallized. Germany's focus on technical brilliance had produced incredible machines. But brilliance alone could not win a war against a system designed for sustainability, efficiency, and mass deployment. The Sherman represented a philosophy that embraced practicality over perfection, resilience over spectacle, and mass availability over individual superiority. Each of these elements worked together to create a force Germany could not hope to match in scale or longevity. The engineers came away with more than just knowledge about an enemy tank. They came away with insight into why Germany was slowly losing the war. It wasn't poor tactics or flawed leadership that had brought the front lines into crisis. It was the mismatch in systems. While Germany relied on technical mastery that required perfection, the Allies relied on a machine that worked when perfection wasn't possible. The Sherman, in its simplicity, reliability, and ease of production, had revealed the strategic flaw in German thinking. They had underestimated the value of industrial and logistical superiority. And that miscalculation was now clear as day. By the end of their analysis, there was no denying it. Winning individual tank battles was no longer enough. To win the war, Germany needed a system that could match the Allies not in brilliance, but in endurance, resilience, and sheer numbers. That realization, bitter as it was, underscored the uncomfortable fact that technical genius, unbacked by scalable systems, could not carry a nation through the realities of total war. And in that moment, staring at a tank that seemed ordinary yet unstoppable in practice, German engineers finally understood one of the key reasons why they were losing the war.